In this session, we'll look into how can we apply what we had learned before, which is calculating the value of G at a certain height from by using G equals Gm over R, the radius, plus H, the distance for the surface of Earth, of the planet, any planet. So this is distance from surface. R is the radius of planet, star, objects. M is the mass of object, star or planet. G gravitational constant 6.67, and this is the gravitational acceleration. So we look into this one, how to apply this formula in our calculation. So let's take out an example. Okay, I will bring here this question. Okay, this question. So let me make it smaller. So calculate the acceleration due to gravity G experienced by International Space Station ISS orbiting 400 kilometers above the Earth's surface. So here they had drawn for us. Okay, we have the planet, which is the Earth, and then outside the atmosphere of the Earth we have ISS orbiting the planet, where the distance from the surface of Earth is equals to 400 kilometers. So all the data had been given here. We have mass of Earth, radius of Earth, and altitude of ISS, H, or the distance of ISS with the surface of Earth equals to 400 kilometers. So now from this question, we know that this object where the ISS, okay, this is ISS, so ISS is placed at certain height. So we have certain height. That means it is not exactly on the surface of the planet. If it is placed on the surface of the planet, then we can use GMM. So this one, if it is on the surface, because we can use G equals to GM over R square. So since this object is placed at certain altitude, so we need to use this equation. G equals to GM over the distance, which is equal to radius of Earth, okay, radius of Earth plus the height square. Okay, and then G, okay, what we are going to do, we need to substitute all of the value. So G, which is the gravitational constant, G 6.6167, okay, times 10 to power of minus 11, and then times 6.67 times the unit Newton meter square kg minus 2, okay, times the mass, okay, mass, so this is the mass of Earth equals to 5.97 times 10 to power of 24 kilogram, okay, divide by, we have R here is the radius of Earth, okay, we can substitute with radius of Earth, so R radius of Earth is equals to 6.38 times 10 to power of 6 meter plus, okay, since the G here, okay, G here, let me change it into another color. So G here, the value of G here, the unit is m square, or it involves meter. So whenever you are given the distance in kilometer, okay, kilometer, you need to change to into meter. So that's why we take the radius or the height is equals to 4, okay, 4 times 10 to power of 5 meter, which is equivalent to 400 kilometer. And don't forget to square. Okay, so don't forget to square it. So let's divide our pages, okay, and then let's continue. Okay, then take out your calculator there. Okay, take out your calculator. Okay, take out your calculator and let's calculate together. So 6.67, okay, 6.67 times 10 to power of minus 11, okay, minus 11 times okay, we do the upper part first, times 5.97 times 10 to power of 24, okay. So this is the upper part or the numerator, and then divide by, so now it involves square, so we need to use bracket, divide by 6.38 times 10 to power of 6, okay, 10 to power of 6, and then plus 4 times 10 to power of 5, and then don't forget to square it, okay, square it. So we will get, okay, the value of G, okay, the value of G, so G equals to 8.66 meter, okay, unit is meter per second square. Of course, we can double check our unit here, okay. So below we have M, okay, how to check your unit. So we have G M over R plus H square, okay. So unit for G is Newton meter square kg minus 2. Unit for mass is kilogram, and unit for R plus H here is meter, and then meter square, it will become meter square. So what will happen to our unit here? Meter square cancel out, okay, cancel out. Kg and kg, we have Newton, okay, kg minus 2 plus 1, like what you did in your maths, x minus 2 times x power 1, you'll get x minus 2 plus 1. So this is kg minus 1. So Newton we can convert to into Newton equals to kg ms minus 2. So it become kg ms minus 2 times kg minus 1. So kg 1 and minus 1 we can cancel out. So what we left here is meter per second square. So that is how you can determine the unit for your G. So this is the value of G experienced by this satellite. Yeah, by this satellite. So that's mean if you go there, this is you go to the height, okay? Not only apply to the satellite, but also any other object. If the object is placed at the same height with this one, which is 400 kilometer, okay, it will experience the value of gravitational acceleration equals to 8.66 0.66 meter per second square. Okay, that's all for this example, and thank you.